Okay, turning to problem 2, we have a similar type of problem as we had before, but now instead of telling you the position of every point, we actually have a gridded space here. So these lines, these horizontal lines you can see here are 10 centimeters apart. So we have to use that to determine the position of this point. So point A here I can see is 20 centimeters, right? 20 centimeters below the surface of the ground. And we're actually supposed to use the surface of the ground as datum. So we'll write down the equations we need here. We know that H equals Z plus psi, and we know that psi equals P over rho G. So in this case, we're given the pressure, P, as negative 3,600 pascals. So we're going to first plug into our equation for psi to calculate it. So psi will equal negative 3,600 pascals over rho G. And we're going to do this whenever we use this equation here. We are always going to do it in the MKS system of units. Always do that in which pressure is pascals, density will be in kilograms per cubic meters, G will be in meters per second squared. So these are constants that you should know. They're actually listed at the bottom of the problem, but the density is 1,000 kilograms per meter cubed, and G is 9.81 meters per second squared. And if I carry through that math, I end up with a psi here equal to negative 0.37 meters. Okay, so again, remember this Z that I showed here, this value here was in centimeters. So let's do everything in terms of meters, okay? So 20 centimeters times 100, times 1 meter is equal to 100 centimeters. So the centimeters are cancel. This will equal then 0.20 meters. So my head, first thing I need to do, using the surface as datum. Oh, I actually haven't talked about that. Okay, so this is 20 centimeters or 0.2 meters below the surface, below datum. So Z here then, I should write this down here, Z is equal to negative 0.20 meters. By the way, the reason I'm showing this with two significant figures is I think you can see from the diagram that I certainly know it. I certainly know my answer to about 1 centimeter. So this number 20 is actually 20 plus or minus like half a centimeter, or in other words, it's known to two significant figures. So I'm showing my answer here to two significant figures. I think that's a very reasonable interpretation of my drawing. So Z is negative 0.20 meters. Psi here, I already calculated, was negative 0.37 meters. So H equals Z plus psi is equal to negative 0.20 meters minus 0.37 meters. That will equal negative 0.57 meters. That's the head at A. That's the first part of our answer. The second part asks us to determine whether water is flowing down or upwards between A and the water table. So once again, we need to determine the head at the water table. So the water table down here, let's pick a point on the water table right there. We'll call it B. Point B is on the water table. And we're going to determine, actually I should put it, let me just, head's only going to be moving up or down. So I should put this directly beneath point A. There we go. So there's point B on the water table. So we have to figure out the head at point B. Well, once again, that is going to be the elevation head at point B plus the metric potential at point B. So metric potential, this is going to be the easy part. This is just equal to the pressure at point B divided by rho G, but we're on the water table where the pressure is defined to be, this is equal to 0. So on the water table, the metric potential is always going to be equal to 0. So that part is easy. This is 0. But the elevation head at the water table in this case is not 0 because we're choosing as datum the surface, and we have to count it down, right? That's 10 centimeters, 20 centimeters, 30 centimeters, 40 centimeters, 50, 60. So this is distance here between, that is 60 centimeters, or 0.60 meters. And so Z, the elevation head for the water table, it's 60 centimeters or 0.6 meters below datum. So this is going to be equal to negative 0.60 meters. And so therefore, the head at B, write it down here, this thing here, will equal negative 0.60 meters plus 0, or just negative 0.60 meters. So again, we'll write them down in different colors here just so that we're clear what we're comparing here. So on the water table, we had the head was equal to negative 0.60 meters. At point A here, the head was equal to, there it was right there, negative 0.57 meters. So which is a larger number? Well, the head at point A is actually larger, right? It's larger. It's closer to 0. The H head at the water table is more negative. So therefore, the water will be flowing down between point A and the water table.